Hey, I'm Daddy from Austin Daddy Doodle Doo, and I have the solution for renewable energy into the transmission scale grid, right? And this I do claim is my intellectual property. So, right now, as we decide that carbon is bad to release in the environment, we have solar panels, right? So here's the sun, right? And then we have wind turbines. So forgive my bad artistry, but we have wind turbines, right? So wind comes in here, right? The current problem is these devices, well, wind turbines maybe not so much, but let's talk about solar panels, right? Solar panels provide DC power, right? And we'll call this V plus, right? Plus. And the transmission system uses AC power to provide everything for our houses. Now, we can talk about how a DC product might be beneficial since everything in your house except for your refrigerator and your air conditioner runs on DC after it's converted. We'll talk about that in a different video. So right now, we have this VC plus, right? So what we would do normally is we draw this other thing called or V plus, right? So we know these are tied together. And this DC signal from the solar panels goes into an inverter. We'll abbreviate, even though I don't like abbreviations, I and V, right? And so this, and we'll ground this, right? So this is AC power. We could model this as AC power. There are a couple problems with this. One, these solar panels only generate when the sun's shining, right? So if we have a cloud, this is my version of a cloud that moves over it, then it's interrupted, right? Or if the wind's not blowing, then we got a hard break on the windmills, right? That's one problem. There's another problem, and that's these inverters. Semiconductors are what's in our phones, our cars, and everywhere these days. Everything's digital when it comes to computation, right? And power delivery in inverters. But outside of inverters, our transmission system does not rely on semiconductors, right? And these things catch on fire. There's fire, or they just don't work. But there is a solution. One solution we've come up with is batteries, right? So we cross out this line, not to the power that goes to the inverter, right? But now, out of the solar panels, we're picking on solar panels today, they go into this battery. So this is how we would draw a battery in schematics, right? And so what that allows us to do is take the energy that we get from the solar panels or the wind farm, store it in a battery, and then when it's time, distribute that energy through this V plus to an inverter that goes to the transmission system. But again, these inverters are tricky and they don't work really well, but there is a solution. So as you may have guessed, one of the problems is this inverter. So let's get this inverter out of the way. All right? Let's stop using inverter semiconductors to try to change DC power into AC power. Because it doesn't work. It doesn't work well. It doesn't work enough for us to count on it for our hospitals, for our libraries, for our homes, right? So what we do is we have this battery that we're charging with renewable energy like solar or wind, right? And then out of here, we run PWM. There's PWM, which stands for pulse width modulation, right? And this is going to seem real simple to a lot of us, including me. We come out of here and we put it into a DC motor. Yeah, I think I put it in there, right? DC motor. So we got renewable or solar panels, in this case, charging a battery, and then a controlled, so let's go ahead and draw that, a control block here to a DC motor. Now out of this DC motor, we have a physical shaft that runs into a 3-phase generator. Right, now this might seem kind of harebrained, but the fact is we can't count on solar for reliable transmission level generation. We can't. And even batteries used to have to go through an inverter to join our transmission system, and those things catch on fire and everything else. All right, so now we have a contributor to energy charging a battery, right? And we have a control that can tell when the battery is charged or not, when it's ready. We have a DC motor modulated by pulse width modulation, which we know works very well. And we have a 3-phase generator, the same generator that we use at every other generation site. And then from here, we'll call this VT for transmission voltage. All right, so what happens here now, and this is a solid idea. And again, this is my intellectual property. So if you want some of it, let me know. What we're going to do is we're going to charge this battery, and battery technology is evolving all the time. We're going to use the energy stored in that battery, pulse width modulated to a DC motor, which DC motors are so efficient compared to any other kind of motor. We're going to run that through a shaft. That's right, shaft. Yeah, shaft in cursive. To a 3-phase generator. And now we can contribute power to the transmission system. All right, so why is this a good idea? There are a couple reasons. One, now we know how much energy is stored in this battery. Right? And we have this control that tells the pulse width modulator how to act, how to drive this DC motor, which in turn, with excitation coils and such, causes this 3-phase generator to put energy and power. Power is the time distribution of energy under a transmission system, VT, right? So now we've got this control center. Control center. Right? Sorry for my penmanship there. And it can speak to the site and say, okay, so you've got 100 megawatt hours in that battery. I would like 25 megawatts for 4 hours. Go. And then it goes. The same generator we use everywhere else. There's a transformer in here, right? To step it up. GSU. So let's go ahead and put that in there. All right, generation step up transformer. And now, when we're looking at how can we serve the load that we now have, because we found out that doing everything with electricity is more efficient, right? But we have to have that energy, right? We can have that energy from nuclear plants, from gas turbines, from coal plants, however it goes. But in this case, we're using solar panels that simply add to this battery, right, as they can. And then we measure how much energy is in this battery. And our transmission control center says, okay, we could use 25 megawatts. And then we drive this DC motor, which turns a 3-phase generator, goes through a generating step-up motor, a generation step-up transformer, and puts it on the transmission system. So we keep our, we keep our hospitals going and everything else, right? So that is the answer. And again, I'm claiming this as my intellectual property. So if someone else has already claimed this, then my bad. But if not, feel free to reach out to me if you want to use this, because this will integrate renewable energy into the grid so that we can use it, so we can keep the lights on. Thanks for watching.